All right. So we've dealt with torques, which are basically using forces to make something rotate or turn in place. We've dealt with mechanical advantages, which are more or less based off of the formulas from torque. Now we want to see what happens when things are actually spinning. So radians per second. Radians are um, some units we've actually been avoiding so far. Some of you may have had trouble back when we were dealing with trigonometry and angles, trying to swap your calculators into degrees mode. You may have been getting negative and weird answers that didn't make sense, and that's because your calculator was in radians mode. Well, in this case, this is actually what we want. So radians are typically good um, for changes in rotation. We may be more comfortable with RPM, but we have to change from one kind of RPM to another number of RPM over a certain period of time. That gets really messy because does it become RPM squared? Does it become uh, per minute, per second, per minute, per hour? Like these things get strange. So that's why radians per second is typically preferred. This question is really just a conversion. It's an important one though, so it's set up as its own question all by itself. All right, so we've got our number 3863. For convenience, stick it over 1 so it looks like a fraction and makes our conversions line up better. Um, we want to look at RPM. Remember, it's rotations per minute, or I think your book says revolutions per minute, so we'll go revs per minute. So revs on top, minutes on the bottom. And we want radians per second, which unfortunately means that both of those units need to change to something else. We don't like either one. You're probably more familiar with minutes and seconds, so I'll do that conversion first before we have to dip into something strange. If we put minutes on top, then we can see hopefully where those will cancel. And if we're trying to get to radians per second, well, revs per second is on the way. Then we need to know how these things go together. I'm assuming everybody knows that 1 minute is 60 seconds. Okay, so that gets us part of the way through the conversion that we need. The other thing we've got to fix are these radians, and that's the part that might be brand new for some of you. One revolution or rotation or one complete time of turning around in degrees is 360 degrees. But in radians, because it's related to um, certain other formulas, so like the area of a circle, different pieces of a circle, you see 2 pi r, pi r squared. The pi that shows up in that is actually from radians. So it sounds funny, but finding the circumference of a circle or the area of a circle directly using, quote, the true method is actually a calculus 2 question, which is really weird to think about. The only thing we need from that is just to borrow the very basic concept that a rotation or a revolution is 2 pi radians. Well, in fact, just rad because that's how it's abbreviated for the final part. So I know it's a bit strange, probably something you haven't seen before, but it makes sense to an extent. Circumference is 2 pi r, and it's related to this same fact. So if we look now, minutes will cancel minutes, revs will cancel revs from way over here. What we're left with are radians and seconds stacked with the radians on top, and so that does match what we're looking for here. Trying to evaluate this, um, we can get an answer all together because there's only one thing on the bottom. So you can take 3863 times 2 times pi and then divide by 60. Just do that all as one run, and you can get the answer directly. So I was going to set up and do 2 parts, but it's more efficient to do it the other way. Also, hold on, my document just got really mad at me. All right, here we go. Okay, let's try that again, hopefully without spastic software. So 3863 times 2 times pi divided by 60, you can do that all in one run, gives you 404.53. Looking at the units left over, we had radians left on top, seconds on the bottom, and again, that's what we're looking for.